Alright, so in this section, we will reveal what techniques are used when working with traditional data, big data, BI, traditional data science methods, and machine learning. Once we've covered that, we will provide examples of where these disciplines can be applied in real life. Entering the field of data science means you will encounter the terms that you can see in these rows of the infographic often. It is essential that you are able to relate each of them to the appropriate column. But worry not, as this section aims to support our infographic with definitions, visuals, and real-life examples to help you do this. Alright, let's get to it. In this video, we will focus on the first block of this row on the infographic. Approaches and techniques specific to working with traditional data. Data is a very broad term that can refer to raw facts, processed data, or information. To make sure we're on the same page and to better understand the different techniques that are applied to a dataset, we will separate those phrases. Take a look at the following graph. People gather raw data that must be processed to obtain meaningful information. Great! Raw data, also called raw facts or primary data, is data which cannot be analyzed straight away. It is untouched data you have accumulated and stored on the server. The gathering of raw data is referred to as data collection. This is the first step. Data can be collected in several ways. One example would be the use of surveys, asking people to rate how much they like or dislike a product or experience on a scale of 1 to 10. Alternatively, gathering data could be automatic. Cookies are a common example of this. They provide companies with detailed information about a user's activity on a website. Both examples can give companies a good idea of how to help improve customer satisfaction. But not yet. This data can have various problems with it. Before it is of any use, it must be processed. Okay, good. Now, let's look how the processing step takes place and can turn raw data into useful and meaningful information. The first thing to do after gathering enough raw data is what is called data preprocessing. This is a group of operations that will basically convert your raw data into a format that is more understandable and hence useful for further processing. So, let's put this tool between raw data and processing on our graph. Great! So, what does data preprocessing aim to do exactly? It attempts to fix the problems that can inevitably occur with data gathering. A problem, for example, within some customer data that has been gathered, you may have a person registered as 932 years old, or see United Kingdom as the name of a person. Obviously, those data entries are incorrect. Before proceeding with any type of analysis, such data must be marked as invalid or corrected. That's what data preprocessing is all about. Perfect. So, let's delve into the specific techniques that are applied while preprocessing raw data. One technique is class labeling. This involves labeling the data point to the correct data type, or arranging data by category. One such category is numerical. For example, if you are storing the number of goods sold daily, then you are keeping track of numerical values. These are numbers which can be manipulated, such as the average number of goods sold per day or month. The other label is categorical. Here, you are dealing with information that cannot have mathematical manipulations. For example, a person's profession or place of birth, as this just provides information about them. Great! Another technique you need to be familiar with is data cleansing, also known as data cleaning or data scrubbing. The goal of data cleansing is to deal with inconsistent data. This can come in various forms. Say you are provided with a data set containing the U.S. states and a quarter of the names are misspelled. In this situation, certain techniques must be performed to correct these mistakes. Missing values are another thing you will have to deal with. Not all customers will give you the data you are asking for. What often happens is that a customer will give you his name and occupation, but not his age, for example. Now, what should you do in that case? Should the customer's entire record be disregarded? Or perhaps you should just enter the average age of the remaining customers. Data cleansing and dealing with missing values are problems that must be solved before you can process the data further. Great stuff! Now, let's move on to a couple of approaches that are specific to working with traditional data. The first one being balancing. Imagine you have compiled a survey to gather data on the shopping habits of men and women. You want to ascertain who spends more money during the weekend, for example. However, when you have your data, you notice that 80% of respondents were female and only 20% male. The trends you may notice are not going to be towards men as much as they are to women. To counteract this problem, applying balancing techniques would be the best thing to do, such as taking an equal number of respondents from each group, so the ratio is 50-50. Another common approach is data shuffling. Shuffling the observations from your dataset is just like shuffling a deck of cards. It will ensure that your dataset is free from unwanted patterns caused by problematic data collection. Data shuffling is a technique which improves predictive performance and helps avoid misleading results. But how does it avoid delusive results? Well, it is a detailed process, but in a nutshell, shuffling is a way to randomize data. If I take the first 100 observations from the dataset, that's not a random sample. Observations that were entered first would be the first to be extracted. If I shuffle the data, I am sure that when I take 100 consecutive entries, they'll be random and most likely representative. All right. Finally, we would like to show you two visualizations frequently associated with databases containing traditional data, or in a more technical language, relational database management systems. The first one represents an entity relationship diagram, or an ER diagram. It is a complex, theoretical way of illustrating a database architecture. Specialists love it for the straightforward way in which the different shapes convey how the tables in a database are related. The second model is important to be understood well, not only by database creators, but also by its users. It is called relational schema. Here, each rectangle represents a distinct data table, and the lines show which tables are related and which aren't. Perfect! To recap, data collection and pre-processing are essential for quantitative analysis. While there are many more techniques that can be applied to traditional data, we wanted to show you the most frequently used techniques out there. Thank you for watching.